Okay, so I've got a piece of graph paper. Here's our coordinate plane. The x values go horizontally from left to right, and the y values go vertically, so up and down. And our first ordered pair that we're going to graph is 1, 6. So that means along the x-axis we go over to the right positive 1, and on the y we go up 6 because they're both positive. So going to the right is positive and going up is positive. Going to the left is negative and down is negative. And you can see I have the values in there. So let's put 1, 6 on. So that's our first point. The next point was 2, 10. So 2 on the x, 10 on the y, 3, 14, and 4, 18 we can get on, but we can't get to the last one. The last one would be up here somewhere, but it would definitely fall in line because we know lines go on forever. So we only needed 2 points, but we have 4. So you're going to use your ruler. Maybe this isn't going to be perfect if I'm going to use pens, but you need to be as perfect as you can here. It matters. This matters now, girls. So we would have something like that. And how would we label that? Well, we would say y equals, what was our relation? Our relation's right here. So that's the name of our line. Did I circle that? Right here. So y equals 4x plus 2. So there's our first line, but again, we're going to try to find some shortcuts because that's a little bit too much, right? Okay, so how about if we try this? Let's just try this. Let's say use some ordered pairs to graph, so in other words, to graph a line, to graph the following relations. Okay, so y equals 2x plus 2. And I'm going to put a table here. So that's the first one. Number 2, the relation is y equals 2x minus 2. And we're going to put our table here. And 3 is y equals 2x. Okay, so we're going to make the same table as we did last time. If x is then y is. Okay. Okay. So you can certainly pause this and then do your own thing here. Let's just pick some real easy numbers here. So, like on the previous page, we'll just do 1, 2, 3, 4, 5. So we're going to make x1 and generate the y, 2, generate the y, 3, 4, and 5. So we're going to plug in the x into this relation and get the y. 2 times 1 is 2 plus 2 is 4. 2 times 2 is 4 plus 2 is 6. 3 times 2 is 6 and 2 is 8. 4 times 2 is 8 and 2 is 10. And 5 times 2 is 10 plus 2 is 12. So we're going to put this on that same graph. Okay. And then our next one, if x is, we're going to pick the values for it, 1, 2, 3, 4, 5. And then y is, I don't know. That's what we're doing. We're going to figure that out. Do you know what I mean? Like, do you know what I'm saying? We're not going to do this every time, girls. We're going to start doing shortcuts, but you have to appreciate how it actually works before we can do shortcuts, okay? So again, we're going to go 1, 2, 3, 4, 5. Don't forget the operation this time is minus 2, not add. 2 times 1 is 2 minus 2 is 0. 2 times 2 is 4 minus 2 is 2. 3 times 2 is 6 minus 2 is 4. 4 times 2 is 8 minus 2 is 6. And 5 times 2 is 10 minus 2 is 8. Okay? So let's do the next one. This one's a little bit different. So yeah, you don't need to watch me do it. You can check your work after if you like. Or we could do it together. I always find doing stuff together is a little less intimidating, especially if it's our first time doing something. If x is, we don't know, we're going to pick it. Then y is, that's the value that we're going to generate. It's 1, 2, 3. Doesn't matter which numbers you pick, I'm just keeping this very consistent and very simple. So 1 times 2, 2. 2 times 2, 4. 3 times 2, 6. 4 times 2 is 8. And 5 times 2 is 10. So these are ordered pairs, girls. It's going to be 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 0. Remember, x value always goes first, followed by the y. 2, 2, 3, 4, 4, 6, and 5, 8. And the last one, 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. Drop my ruler. Okay, so we're going to put these on our graph paper. We can probably fit them on here. Okay, so let's graph 2x, y equals 2x plus 2. So we need to start with 1, 4. I'm just graphing these girls. 1, 4, 2, 6, 3, 8. 2, 6. 3, 8. And 4, 10. And 5, 12. So do we have 2 points? Yep. Maybe I can use different colors. So you take your straight edge. Be very careful here. This can't be a mess. And this is This line is called y equals 2x plus 2. Of course, we would have arrows on all of these because these are lines, these are not line segments. Okay, so now we're going to graph y equals 2x minus 2. And this minus is going to have an impact on the way the graph goes. So I'm graphing these. 1, 0, 2, 2. That's 1, 0, 2, 2, 3, 4, 4, 6, and 5, 8. These are lines, and this one's called y equals 2x minus 2. What kind of lines do you think I just drew? What are those called? Train tracks, remember? Alright, we could put little train tracks in here. Remember the lines that go on forever and never cross? Those are called parallel lines. And that has everything to do with this. Anyway, we'll talk more about that later. And then we have one more to go. Y equals 2x. What's this one? So we're graphing these. 1, 2, 2, 4, 3, 6. Oh boy, it's going right in the middle of the train tracks, man. 4, 8. 5, 10. There's another line that doesn't touch. So we got a line right in the middle of the train tracks that doesn't touch. And this one's y equals 2x. This is important. Look, all three of them have that in common. And we have three parallel lines with three relations. If this number is the same, the number in front of the x is the same, that means we have parallel lines. And in this case, we have three parallel lines. Okay, so I'll stop that there and then I'll post it up and we're going to move on.